Have you ever wondered how semiconductor devices are made? The answer lies in a fascinating process known as epitaxy, a technique used to grow or deposit a single crystalline layer on a substrate. It's like building a layer cake, where each layer must align flawlessly with the one beneath it. Now, depending on the nature of this crystalline growth, we can classify it into two types: heteroepitaxy and homoepitaxy. Heteroepitaxy is a bit like a fusion cuisine, where two different types of ingredients come together to create something unique. It's the process of growing one crystal on a substrate that has a different crystalline structure. Imagine trying to build a brick wall on top of a wooden table. The bricks are your growing layer, and the wooden table is your substrate. They have different structures, but with careful planning and execution, you can create a stable structure. An example of this in the semiconductor world is growing gallium arsenide on a silicon substrate. These two have different lattice constants, the measure of the physical size of a crystal's unit cell. Yet, with controlled conditions, a layer of gallium arsenide can be deposited on the silicon substrate, creating a heteroepitaxial structure. This technique is widely utilized in the semiconductor industry to combine materials with specific properties into a single device. On the other hand, homoepitaxy is more like traditional cooking, where the same ingredient is used throughout the process. It involves growing a crystal layer on a substrate made of the same material. In this scenario, the crystal lattice structures of the substrate and the growing layer are identical. It's like building a brick wall on a brick foundation. An example of homoepitaxy is the deposition of an additional layer of silicon on an existing silicon substrate. It's a common practice in semiconductor fabrication processes to create uniform and continuous layers of the same material. This ensures consistency in electronic properties, which is crucial for the device's performance. In conclusion, heteroepitaxy and homoepitaxy are two fundamental techniques in semiconductor manufacturing. Heteroepitaxy allows for the integration of different materials into a single device, opening up possibilities for new functionalities. Homoepitaxy, on the other hand, ensures the consistency of the material's properties, which is key for the reliability of the device. Both have their unique strengths and applications, and understanding them is essential to appreciate the complexity behind the electronic devices we use every day.